ready to implement a complete authentication flow where users log in with credentials and automatically get JWT-based access control. You'll see how to build a FastMCP server that handles login requests, issues signed tokens, and then uses those tokens to enforce role-based permissions, all while keeping the code clean and the security tight. The middleware does the heavy lifting, so you just define the rules.
From FastMCP, import FastMCP. Context. From permit FastMCP, middleware. Middleware import permit MCP middleware. Import JWT. Import data time. Hash configure, JWT identity extraction. OS environ, permit MCP identity mode equals JWT. OS environ, permit MCP identity JWT secret equals MySecret key. MCP equals FastMCP, my MCP server. At MCP, tool. Def login username, SDR password, SDR. A login to get a JWT token. If username equals admin and password equals password. Token equals JWT and code. Sub username exp datatime ukno plus datatime time delta hours equals 1. MySecret key. Algorithm equals HS 256. Return fbearer token. Raise exception, invalid credentials. At MCP, tool. Def greet JWT CTX, context, SDR. Greet a user by extracting their name from JWT. Hash JWT extraction, handled by middleware. Return, hello, authenticated user. MCP, add middleware, permit MCP middleware. Permit PDP URL equals http://localhost 7766. Permit API key equals your permit API key. If name equals main. MCP, run transport equals HTTP.
This demonstrates the authorization middleware pattern for adding policy-based access control to RPC servers. The code shows how to integrate Permit.io's authorization layer into FastMCP, creating a separation between business logic and access enforcement. What makes this distinctive is the automatic mapping of RPC methods to authorization resources and actions, eliminating manual permission checks in your tool implementations. The pattern works by intercepting all incoming requests through middleware that validates permissions before execution. The middleware extracts user identity, here via JWT, maps the requested operation to a resource action pair, and checks against Permit.io's policy decision point. This creates a declarative security layer where access rules are defined externally, keeping your server code clean and policy agnostic. This approach solves the common problem of scattering authorization logic throughout your codebase. By centralizing access control in configurable middleware, you gain consistent enforcement, audit logging, and the ability to modify policies without code changes. It's particularly valuable for multi-tenant systems, admin interfaces, or any scenario where you need fine-grained access control without compromising code maintainability. Let's break it down.
From FastMCP, import FastMCP. Context. From permit FastMCP, middleware. Middleware import permit MCP middleware.
Imports FastMCP for creating AI-callable tools and context for tool metadata access. The permit MCP middleware handles JWT authentication and authorization, integrating with permits policy decision point for secure tool execution.
Hash configure, JWT identity extraction. OS environ, permit MCP identity mode equals JWT. OS environ, permit MCP identity JWT secret equals MySecret key.
These environment variables configure JWT authentication for FastMCP. Permit MCP identity mode sets JWT as the identity extraction method, while permit MCP identity JWT secret provides the shared secret for token verification. This enables automatic user authentication from incoming JWT tokens in subsequent requests.
MCP equals FastMCP, my MCP server.
This initializes the FastMCP server instance, the core orchestrator for AA callable tools, all decorated at MCP. Tool functions will register with this instance, making them discoverable and executable by AI models. The server name parameter identifies this instance in logs and monitoring systems.
At MCP, tool. Def login username, SDR password, SDR. A login to get a JWT token. If username equals admin and password equals password. Token equals JWT encode.
This defines a JWT authentication endpoint exposed to AI models. The @MCP tool decorator makes it callable by AI agents, while the hard-coded credentials demonstrate the basic auth to JWT flow before integrating real authentication. In production, replace this with your actual auth system.
At MCP, tool. Def greet JWT CTX, context, SDR. Greet a user by extracting their name from JWT. Hash JWT extraction, handled by middleware. Return, hello, authenticated user.
This tool demonstrates FastMCP's middleware integration for JWT authentication. The CTX context parameter is required for all tools, enabling middleware like Permit MCP middleware to inject the authenticated user identity before execution. Notice we don't manually extract JWT claims. The middleware handles this automatically, keeping the tool implementation clean.
MCP, add middleware, permit MCP middleware. Permit PDP URL equals http://localhost 7766.
This registers the permit middleware for authorization checks. It connects to the local policy decision point at localhost 7766, which evaluates access rules before any tool executes. Middleware pattern ensures consistent auth across all FastMCP tools.
If name equals main. MCP, run transport equals HTTP.
This is the standard Python entry point guard. It ensures MCP, run, only executes when the script runs directly, not when imported as a module, preventing accidental server startup during imports. The HTTP transport parameter configures FastMCP to serve tools over HTTP endpoints. FastMCP JWT integration. This pattern demonstrates how FastMCP tools become AI callable while maintaining stateless authentication through JWT, where the token carries both identity and expiration without server-side sessions. The JWT secret in environment variables must match exactly between issuer and verifier, or all tokens will silently fail validation. Always validate the sub, claim in your tools to ensure proper user context propagation.
The token that reveals everything hides the moment it's created.